Associate Director of Network Services at CSU Monterey Bay. He serves as the Chairman in CSU's Network Technology Alliance in 2013. He came from a corporate networking background to the CSUs in 2006 and has been the Director of Network Services at Monterey Bay since 2011. In the last 2 years, he's worked closely with CSUs, Chancellor's Office on many projects, including chairing the CSU System-Wide Network Technology Alliance in 2013.
Right. Thank you. No signal. There we go. How are we doing? Everybody see that okay? Can you hear me okay? All right, thanks. First I wanted to just say thanks to the program committee and everybody for asking me to speak today. Basically I'm talking about my boss right over there, Chip Leno, who's on the committee, and I'm also going to be talking a little bit of a story today about a little bit about me real quick, just so you know why I'm so thrilled to be talking about what I'm talking about. To what CSU Monterey Bay has done with this network. I don't know why that's running by itself. And thirdly, what CENIC's network is now enabling us to do as a campus. Okay, so I've just got a little picture up here of the different CSUs. We got a lot of them. Up in the right-hand corner, just a picture of CENIC's network to indicate that that network covers all of us and how all of these campuses can become, if we want it to, our own fabric for kind of some collaborative services that might save us some money. Who am I? I came from a corporate, a very, what I'll call a humble beginning of just a MIDI musician. I was into technology early after school. I started writing databases and shared stuff over Apple Talk. I thought that was fascinating. So from Apple Talk, PhoneWire to where we're about to go is, to me, it's just been a great journey. I then went over to Pebble Beach, got a real job where they had me doing everything under the sun. Basically, servers, storage, sand, fiber, cell towers. Anybody ever played golf over there? It's not just a golf course. They've got 4 hotels, 3 spas, 40 food and beverage outlets. They got shops all over town, gates. I mean, it was a crazy network to learn on, especially during I'll say the evolution of a lot of this networking that we're all doing today. Finally, in 2006, I met a guy named Gil Gonzalez, who was the CIO at the time at Monterey Bay, and he and I were volunteering at our kids' schools together. And he said, "Hey, I got a job for you," and so I made a lateral move to the CSU, where I was able to use a lot of that experience at Pebble Beach. Doing basically as their NetApp lead first, just servers, storage, data center stuff. In 2011, a guy named Chris Taylor, that many of you may know, was one of the people instrumental in getting CENIC going way back when, retired, and Chip advanced me to help run the network. And then last year, I was able to have the great experience of chairing the NTA for the CSU, which is, so it's taken me quite a ways to get a perspective on what I'm about to show you. I'm just going to talk a little bit about the network evolution at CSUMB itself. When I got there in 2006, they had just started virtualization, as many companies had, or enterprises had at that point. They also had an Avaya PBX that they didn't know could do VoIP, and so I bought a couple cards and threw some VoIP in it, and we started doing VoIP at that point. In 2007, the Technology Infrastructure Upgrade, or TIU project for the CSU, tried to level the playing field on all the campuses and bring in infrastructure, and they actually built us a new data center. We were on the old Fort Ord. We had really old Army infrastructure. So they bought us and built us one nice new server room, and we were able to retire our old server room at that point. In 2008, they built us a library. A little picture of it up on the right there, what it looked like as a conceptual drawing. But in there, At the time they drew it up, we thought this was going to be another place that needed a huge server room with lots of telephone cabinets, and it didn't work out that way, but we did get another second data center out of it on the campus. So that gave us some really nifty options within our own facility to do some things. A couple years later, the Chancellor's office decided that wireless was something that they needed to start sponsoring around the campuses, so they brought in Aruba. I was still just running NetOps, kind of watching all this happen at the time. In 2009, we got our second Gigaman from CENIC, so we had dual now dark fiber circuits. One of them is engineered to go north to Sunnyvale, and the other is going down to Soledad. So now we have diverse pathways off the campus, and we've got 2 gig circuits, so we're moving there, we're getting there. In 2011, CNI was now the Common Network Infrastructure program that the Chancellor's Office sponsors to try and get all the campuses up to a similar level of baseline services for switch and route, access points, security. So as many of you know, we're not with Cisco anymore, so we were one of the last campuses to get some Cisco gear. So they gave me a new access layer, all 3750 V2s. The very next year, ALU was adopted as our switch and route vendor in lieu of Cisco. So that changed things, the landscape for what was going to happen moving forward. There were a lot of campuses that were almost all Cisco. I think a lot of them are today, although they've started to refresh a handful of the campuses last year with all ALU gear. My campus is one of the, what we'll call a mix. I'm Cisco all inside, and we're going to talk a lot about my borders in just a minute. In 2013, we upgraded those borders to 10 gig. At the very end, SRX firewalls from Juniper and ALU borders. And just a couple months ago, Aruba's here also. We put in new 7240 wireless LAN controllers, which also have 10 gig backhauls out of them. So basically what I've been trying to do is build a battleship, right? More specifically, I want to talk a lot more about what happened here in 2013, because battleship is what I call it, but it's really a starship. And you know, we really did make the jump to light speed at that point. There were a lot of things that people wanted to do. Some other campuses wanted to do some stuff with us that we were already playing with, but we really didn't have the bandwidth. We were constrained, right? And I heard a lot so far in this conference of places that are underserved. You know, it breaks my heart when I'm sitting here with feeling pretty spoiled with dual 10 gig circuits right now when I hear about all these places that are underserved. So one of the things we do, just because of our physical location, is we end up providing some service to people that can't get it with an immediate physical footprint of the four-door base. There's only one MPO, and it's our MPO. So we have to help some of those people with our media and getting them connections that are local. But the human adventure is just beginning. You know, with this kind of bandwidth now, it feels like we're not just a little bitty campus that just kind of came off the map. Now we're actually on the map. So this is what we had before. I'm going to talk a little bit about how this went. I'm also going to say kind of thank you for all the vendors that CNI has got together. They're all, I think they're all here, Juniper, Alcatel. AT&T helped us a lot with this project, the Chancellor's Office and the CNI program. But basically we were running out of bandwidth, and so they said, okay, it's time for you to get your circuits. One of the things I did with the NTA was help write a standard network baseline design document. So we have a standard design that we're trying to push out to all the campuses. I think this is a pretty good representation of what that should look like when it's all said and done. But you can see at this point, we got gig links down here. This is all stuff is black. Everything's gig. I've got some Cisco ASRs up on these borders out here. And I've got a CMTS in the middle. That's a cable modem, DOCSIS 3 cable modem system, which serves 1,200 homes east of our campus. These are all our staff, faculty, and students. They were in a nightmare a few years ago, so we upgraded them to a nice new CMTS, and we have a hybrid fiber coax plant, which should deliver enough bandwidth to those people for the indefinite future. An HFC plant can do unbelievable speeds if it's built right. So I'm going to walk you through what it took to get there. Many of this may be kind of elementary for a lot of you folks, but for me it was you know, how are we going to introduce SRXs, Alcatel gear, which, you know, we'll talk about what we put at the borders. And, you know, I'm not a big fan of downtime, you know. I just don't like it. I don't believe in it. We should be able to plan this stuff and cut over it quickly. So we did all right. We had a couple hiccups, but here's how it goes. First thing we had to do was get rid of the gig links down here. Notice we have 6509 chassis. They don't do 10 gig, right? As part of the CNI program, we shuffled around a little bit of gear. I don't know if East Bay is still here, but we got some leftover E chassis from East Bay, and we popped them in real quick. So now I've got 10 gig and E chassis in my cores. I can't do anything without 10 gig to the cores. So we started there. The next step was the worst, I think, the SRXs. I'm not sure if Juniper's here, but you know, they're great tools, but they've got to be configured right. First time we tried to do them, we had a little bit of a problem getting them to come up right, but we did get them on our second attempt. I don't know if you know, but after about 90 minutes of your DNS servers not seeing the internet, you start to disappear on the internet. So we pushed that limit, called it back, came back another day later when we knew it was wrong, and we got them going quickly. So now our SRXs are in, and I've got 10 gig between them, but I'm still gig link from the cores up and gig link out, right? Black links. Then we built in the private net. We built in the Alcatel piece up at the top. You'll notice the Alcatel 6900s, not typically a border router. Not typically. Really more of a top-of-rack data center switch. However, very inexpensive 10 gig solution from Alcatel. And right now they've been functioning just fine, as I'll show you in a few minutes. They're functioning just fine. And so at this point, I've got my first Decaman. You'll notice up on the upper left here, you've got our first Decaman is in, and we've got some connectivity to the 6900s. We can do some testing from this point out, but none of this is engaged yet. It's just a parallel network. And we have a little bit of traffic off to the right. You notice that. In an ideal situation, everything is active, standby. So I'm only going to rely on 10 gig. That's my max. I don't have 20. I have 10 in a failover capacity, because that's the design, and it just makes sense. So CENIC, I want to talk about what they did to help us out here. You notice I just brought in a little temporary link coming from the Soledad side. When they brought up the Decaman, they had a router sitting there and said, well, listen, we want to make sure that other Alcatel can talk. So they actually, and thank you CENIC, they're knocked, hey, how about if we do this? Really quickly, we patched up another circuit. Quick gig link over here with some IP space in our BGP routing that would help us at least test. So we got that done. Now we know we've got two 6900s that'll talk. We've got a config ready to go. And we're going to go ahead and shut down this link on the right, the old Gigaman. We just shut down, and we pushed all of our traffic over onto this other side. And at this point, we're ready to cut. Okay? And then we call the ball in the morning of the cut, Saturday morning, 7 o'clock, something like that. And first thing we do is we pull off the old Gigaman. Now, at this point, the people down here get very unhappy, okay, because we're down. And so things move quickly at this point. We're going to tear out the Cisco stuff. We're going to upgrade the links from the cores up to the SRXs to 10 gig, which is really just shut, no shut on the interfaces. It doesn't take very long. Shut those, unshut those. SRXs come up, and then we did the same thing from the SRXs up to the Alcatels. SRXs are now talking to the Alcatels, and finally we have traffic and everybody gets happy. So that was the essential cut. That was the nuts and bolts of the cut right there. But notice we're still riding on that temp circuit at the top, and so it took them about another week and a half or 2 weeks to engineer the dark fiber because they had to reuse the fibers. So that's one of the reasons we got that out of the picture. And so I'm on one link right now without a net for about 10 days, but we were okay. Alcatel's cranking it out. And I had to build in the rest of these links too for the CMTS and whatnot. So all this, I'm going to call it, they're outside our firewalls, but they're people we have to provide service to, once again, because of their physical location. We'll call them INET customers. But everything's up and running at this point. We're out of the woods. And then finally, they brought up the second Decaman, and we got rid of the last temp. And then this is the picture that we have today. So when I was all said and done, now I'm 10 gig. I got pink everywhere, from cores, SRXs, borders, all the way out. Whew. From Apple Talk to dual 10 gig circuits. All right. Now I'm going to talk a little bit about DR and why we're doing it. Anybody who's been running a data center for any length of time knows why you do DR, right? Offsite backups DR, failover for both data and voice. It's an essential element of, cornerstone of any data center. That, I feel like in the last 15 years I've spent most of my life thinking about failover and redundancy in IT, especially in the network side. I don't think the app people think about it quite as much, but certainly in network, our phones ring when their app isn't running. So CSU and CENIC have been looking at the value of cloud service offerings from commercial service providers, as you all have heard from this morning, and we've all known that CSU has been looking at this. And all this stuff is usually measured in water meters, right? Bandwidth, storage, RAM, right? Whatever you're using in terms of hosting services, depending on what you're buying. I think I'm going to go out on a limb and say there's no clear pathway to savings on all this yet. I know we're working on it, and certainly we're going there, but we didn't have a clear pathway. So in the meantime, some creative data centers at my campus and or other campuses really came to us and said, hey, can we do some stuff that will help us with our DR efforts and our backup efforts in the meantime? And this isn't a very fancy case, but the case I'm trying to make here today is that there's a little organic movement afoot using this fabric that we have that is saving us some money and is really increasing our disaster recovery objectives, okay? And those objectives are simple, right? There's three of them. How fast am I going to return to operations? What point am I going to return to operations? And how much operations am I going to return to? So your recovery time objective, your recovery point objective, and your recovery service level objective are all things that cost money, right? So these are just standard DR concepts. And the one thing that we don't want is any more tape, right? Everybody's good with that. And so this is just another quick picture of, dollars versus recovery time, right? What I'm going to show, I believe is true, is that we're moving the bar that way. We're moving our hot site DR node cost down and keeping the recovery time the same or better by using a sister campus's data center for something simple as an Avamar backup node or an EMC Equalogic SAN to back up a Zimbra data store from Cal Poly. So what are we actually doing, okay? We're collating gear, as I just described, on another campus under an MOU, or Memorandum of Understanding. It's just a, hey, I'm going to put some stuff in your place, and if you want to put some stuff in my place, that's cool. No cost. We'll be remote hands. Everybody's friendly. Kind of a nice environment. An MOU incorporate any number of the raw components. Connectivity, bandwidth, that's the obvious fruit, right? Because CENIC's fabric is letting us do this. Rack space, power and cooling, physical security. We're already running a data center. I got a lot of floor space, got extra rack space. What's stopping me from saying, sure, do this for another campus, right? And you can structure that MOU any way you want. If you want to put a separate power meter and make them pay power or whatever you need to do. In our case, we just said, sure, come on and do it, and we're holding the chip from them for when it's our turn, which is coming up very soon. All these components are generally rolled into the cost and services of an Amazon or a rack space, right? And so when we're looking at this, like I say, I'm not an Amazon or a rack space. That's not what I'm trying to do. I'm not trying to give away my data center resources or say that we're not going to move to the cloud. All I'm saying is in the interim, we've got this infrastructure that we can leverage to do some things that are helping us today. Why are we doing it this way? Well, it's significantly cheaper, if not free, obviously. It's robust and it's secure and it's reliable. I mean, I've been to data centers. I've been to his data center. He's been to mine, and it's just as solid as any commercial data center I've seen. I mean, we have standards that we have to adhere to, and I think everybody does a pretty good job. So we have the advantage of being an in-house customer. I mean, we're friends, right? This is all one organization. So, I'm running out of time. All right. Real quick, this is an example. Long Beach is doing an Avamar node at our campus, and they've been running that for about 5 years. No tape, about 9 terabytes of data. Cal Poly, they've got a VMware remote cluster, a Zimbra mail store offsite. We did them in 2 phases. Well, before we had our 10 gig circuits, they were only running about 50 megs, and I think it was taking 9 hours. Is that right to back up, James? After we did our upgrade, we bumped their limit to 500 megs. They're now backing up in 30 minutes, a 9 gig Zimbra store, mail store. So that definitely moved the ball over, right, in terms of restore time. Real quick estimate of cost savings. These are just numbers I grabbed off the CENIC's website. $850 a rack for co-locating a rack in CENIC's data center, $19 an amp per month. And then most of the commercial data centers will charge you $10 minimal. Starts at about $10 per terabyte for outbound. So when you want to get your data back, it's $10. So I took a couple estimates of how many terabytes, and this is just a rough estimate. It's not a very big number, right? But in 5 years, in 2 years for them, you know, $250,000 in money that they didn't have to go pay for somebody to move their recovery point objective over. So I know there are a lot more examples of this going on. These are just 2 that I have my hands on because they're right in my own data center. Last thing, the VNOC is another shared service we're running over that. This is something I talked about a couple of years ago. It's providing network health performance, configuration management, change control reporting. The 7 campuses are going to go full-time with this in 2014-15, my campus being one of them. So we're going to really be taking advantage of it. The last of this is, what does our move to the cloud look like? I think that there are a lot of considerations for every service. You got security, you got service levels. There are a lot of things. We understand a lot of the stuff has to move. Not sure what it's going to look like, but now that we have the pipes to do it, we feel confident. My point is before we had those pipes, we really couldn't think about some of these things. Next for us, implementing offsite backups. At Cal Poly or SLO, we've got the gear, we've got an engineer, we're going to be knocking on the door to pick up our side of that deal. Same thing, DR, and then we'll start migrating eligible services out as we can. And then finally, telephony. Telephony count at 3 is done. I'm an old voice guy, so for me to be ready to move telephony to the cloud is kind of a big move. And then obviously our 10 gig links inside the LAN so that we can continue to service better. Finally, real quick, reliability, confidence matters. This dropped in my lap just last Sunday night. My primary Alcatel circuit failed. There was a loose fiber in Soledad. And my other circuit took over immediately. Beautiful. So in closing, we can trust the fabric to do things that we couldn't trust it to, or at least I wasn't comfortable trusting. Certainly they're good circuits, but now there's enough capacity to do some things like really work with the cloud, really trust telephony, and that is it. Thank you very much for your time. Questions? Anybody? Okay. Yeah.
What would you tell folks here that want to do this? What would be the first step you tell them?
I would say think about what you want to do on another campus, and then find another campus you like that you can work with, and see if they're willing and got some rack space to spare. You know, it was really just that organic for us. So.
And I would just make one other comment. If anyone is interested in doing this, and you have questions, or you need to come out and see it, Cal Poly is certainly would be willing to to give you a tour or talk to you, do a conference call, whatever, to help you understand what the pieces are and how to do it.
Thanks, James.